Oh, sorry. I didn't see you come in. I'm Mr. Borcherding, and welcome to another edition of First of All, You're Wrong. The part of the show where I explain to you why something you're pretty sure is true is actually not. What we're going to talk about today is falling objects. And in two-dimensional motion, we can fire an object forward while the object falls. So, two-dimensional motion. What most people expect is that if you fire an object forward faster, it'll fall differently than an object that you just dropped, or an object that's going at a slower speed. And I regret to inform you that you are incorrect in that assessment. So let's take a look at an example, because you're probably saying, well, Mr. B, I'm clearly not wrong, because I'm never wrong. Well, first of all, you are. So I went ahead and I set up this simulation. I'm going to put this simulation, a link to it in the video description if you want to try for yourself. So I have an object that is 10 meters above the ground, and I fired the cannon 3 times with 3 different speeds. The first one is a speed of 0, the next one is a speed of 5, and the last one is a speed of 10. And I went ahead and set it so that you can see the velocity vectors, so you'll be able to see the forward velocity vector component and the vertical downward one. The one forward is caused by the initial launch of the cannon. And once it's launched, according to Newton's first law, it won't change. It'll just continue on normally because there's nothing in the x direction to change it. Because again, I guess I shouldn't say again, we're going to assume no air resistance because so if that's the case, then there has to be some force that causes it to fall, and that's gravity. So if we go ahead and start the simulation, I'm going to show you what happens over these short periods of time. And in particular, pay attention to what happens with these downward arrows. So notice that those downward velocity vectors, so the y component vector, are going to slowly increase over time. And the reason for that is gravity. Gravity has an acceleration, 9.8 here for most places on Earth, or at least very close to that. And because of that, all those objects are going to accelerate downward at the same rate. You'll notice the forward arrows don't change at all. This one is twice the size of this one is 0, and they stay that way the whole time because there's nothing to change them, unless I were to turn on air resistance. What I want you to see is that those objects are going to fall and hit the ground at the same time. And if you don't believe me, the time it takes for this one to reach the bottom was 1.43 seconds, 1.43 seconds, 1.43 seconds. Gravity affects all of them in an equal way. The acceleration due to gravity of all 3 is 9.8 meters per second squared. So if that's the case, then they all should hit the ground at the same time, regardless of how fast they're going. So objects do fall at the same rate, no matter how fast you launch them. You could launch them at an infinitely fast rate, and in theory, they should all reach the ground. Now, because Earth is curved, there's some interesting things that'll happen, but that'll be on another edition of First of All, You're Wrong. Thanks, and have a blessed day.